Additive manufacturing is a method that we use to create products of tomorrow using a kind of layer by layer process of printing material upon one another to create a component, sub-assembly or product. Most people might be familiar with it under the guise of 3D printing.
I and the people I'm working with have been looking at additive manufacturing technologies because there's been quite a lot of hype over the last couple of decades around how transformative those technologies could be. My background's in geography, sustainability and circular economies, so I'd been looking at how they can change the geography of production. Then I was introduced to the Digital Manufacturing Futures Lab.
We were looking at lateral flow devices, so they were printed and shipped across from China to here, but actually we could have 3D printed those. The nation has about 200,000 printers. If we were able to have united that capability and used it as one, that could have met all our lateral flow device needs. So we could have printed them in the UK, shipped to local areas where they were needed, and the material, more importantly, is recyclable.
And there is still quite a lot of opportunities for additive manufacturing, but we want to work more with industry to enable them to capitalise on those opportunities.
It's understanding the value add of our solution and really how to adopt it within a business, and that's why we're working with the business school. And now going forward is still that challenge of how do we adopt digital technologies and innovations into supply chains.
A contemporary issue related to this project is supply chain disruptions and the increasing likelihood of these either through geopolitical tensions, through natural disasters, and how can we produce and respond to those disruptions.
We have a living lab at the University of Bristol, which has a host of printers that can network, share workloads, share maintenance schedules. They're doing it totally autonomously using artificial intelligence technologies.
Extracting that and taking it across the supply network is even more difficult, where you've got different organisations with their own capability and you want these machines to talk to the platform you're trying to distribute from. How do we respond with those AI agents to deliver a responsive system?
How do you get agents and machines to trust one another?
That needs to include supplier selection criteria, which is where we work in my field in supply chain management, understanding the regulations and standards the suppliers have and can show and demonstrate, and how the AI agents can autonomously recognise those to build trust to allow work to be distributed. The cybersecurity elements, building in a double lock security system where we have the physical product tagged and the digital design file tagged, and we can match those at the end of the production cycle to make sure they're the same. The benefit really is creating a methodology that allows us to scale up those AM networks with the confidence that we are securing our network against those potential disruptions.
One thing that we want to do with the Living Lab is to almost create a product that we can offer to the Bristol region and then have that distributed across the region, people start using it, and then try to understand how they might want to then reuse it in life. Will they give it to their friends? Will they pass it on? Or will they return it to us because we've got the recycling capability? And we want to start creating the actual research testbed of that circular economy.
All of our research is underpinned with high engagement with industry. We think that's important in terms of co-creating the research right from the start of the process to really understand industry need and connect in the academic relevance. Looking at how disruptive small firms, SMEs, are reconfiguring their supply chains to have sustainability gains. Now, more of them are staying in business than the typical average. We can try to understand perhaps where the barriers are in terms of pushing forward on sustainability initiatives and gains, particularly around the R's of circular economies. So then we can try to understand around sustainable supply chains, but also business resilience, to understand the technologies and their adoption, but also the business models behind them.
The goal of the project is, can we use the additive manufacturing capability within a region to produce products for that region and respond to the demand of that region.
We're also very interested in scaling that up and applying that to other regions and understanding the national and international context of the policy making. It should be easier for us to repair the goods that we own, particularly things like white goods. So in the future, it may be that something breaks, a part breaks in your dishwasher or your washing machine, and the engineer will come and will be able to print a part for you much quicker than waiting for the supply chain. That removes that supply chain, so there's no footprint for that replacement part. And it also means that that part can make the machine continue to work and stops it going to landfill.
We're looking at the use of additive manufacturing and 3D scanning to create digital models of patients' jaws and teeth, benefit of that is you can have your treatment done quicker, and ultimately the experience for the patient is better as they can come in and have a less invasive procedure.
Because additive manufacturing is more distributed, you could ring up and say, I need a spare part for my vehicle. That gets sent encrypted to the machine that's locally near you. It gets printed and then delivered to you. So it's on demand. We only use the material as and when it's needed, and who owns what using digital technologies and cryptography. It's going to fundamentally change how we produce items in the future.
We want to create a UK manufacturing sector that is much more able to weather the ups and downs of uncertainty in the global economy, that is more resilient, but that is also more sustainable.